Okay, so today we're looking at differentiating exponential functions. Now please note we're only going to learn how to differentiate exponential functions of the form e to the power of x. We have very specific rules that work for differentiating this, and we do need to know how to differentiate this in tech-free situations, such as exam 1. We are not going to learn how to differentiate things like 2 to the power of x, 10 to the power of x, or anything else. For these, you would just use your CAS calculator if you had to differentiate these for any reason. So it's only our e to the power of x that we need to be able to differentiate by hand this year. Okay, so the specific rule, in general, when I want to differentiate e to the power of x with respect to x, we actually just get e to the power of x again. Now there are proofs for this that you can look at in your textbook should you wish, however the proofs are not necessary. All that you need to know is to be able to use these rules. Our second option, very similar, but we've got a value of k here, a constant. What happens is that we end up with, if we differentiate this, we differentiate the power. The derivative of k to the power of x is k, and we're left with e to the power of kx again. Our final option is if we have a whole function here. And this is essentially like the chain rule, because what happens is that we differentiate the power, and e to the power of whatever was the power stays the same. So it's the derivative of the power multiplied by the original function. So let's start applying this rule. Okay, we need to differentiate with respect to x. Our first function, when we differentiate with respect to x, we'd be finding dy dx. Our rule is that we multiply by the derivative of the power. The derivative of 5x is 5, and then e to the power of 5x stays the same. A lot of the time people have trouble with this. You need to make absolutely sure whatever our original function is here, we get the same original function here. We're multiplying by the derivative. This part here is the derivative of the power, and the other part of our answer is the original function. Okay, please be careful with this. It is something that does cause people some difficulty at times. But if you remember the rule, and it is on the formula sheet as well, then hopefully this will be okay for you. The second one, we want to differentiate dy, the function y, with respect to x again. So this is our whole power here. So what we do first is we need to have the derivative of the power. The derivative of this whole power here, derivative of x squared is 2x, the derivative of x is 1. We multiply this whole function, our derivative there, by the original function, e to the power of x squared plus x. And that's it. You could expand if you wanted to and write it like so, and 1 times e to the power of x. Okay, but you really do not need to expand, okay? That's an option, but you don't actually need to carry it, so expanding is not needed. And once again, if we have a look at what we had here, this part here was the derivative of the power, okay? So we have the derivative of the power multiplied by this part here, which is the same as this part here, and is our original function. Okay, so this is the rule every time. We have the derivative of the power multiplied by the original function. So if we're looking at these questions here, now there is a rule for when we're dividing functions like this, called the quotient rule, but we haven't learned that yet. The other thing to do when we're dividing by a single term, what we can do is to divide every term in the numerator by that. So what we will get is that first of all I divide e to the power of 5x. So essentially what I'm doing is saying e to the power of 5x divided by e to the power of 3x. Hopefully you remember when the bases are the same, we subtract the powers and we get e to the power of 2x, which is what we have here, minus, now I have e to the power of 2x divided by e to the power of 3x. I subtract the powers, 2x minus 3x gives me negative x. Okay, now to differentiate, make sure you're clear. When are we just rearranging y? As soon as we are actually differentiating using calculus, we must label it appropriately using dy dx. Derivative of e to the power of 2x. The derivative of the power, the derivative of 2x is 2, multiplied by the original function, which is e to the power of 2x, minus the second part, derivative of the power. The power is negative x. The derivative of negative x is negative 1, and then we multiply that by the original function, which is e to the power of negative x. So it gives us 2e to the power of 2x, negative 2 negatives make a positive, 1 times e to the x is e to the negative x. We can leave it like this, or our other options for our possible answers, we could, if we choose, write e to the power of negative x as 1 over e to the power of x. Or another possible answer, not necessary but possible, if we wanted to have e to the power of x as a common denominator, I'd have 1 here. For our other term, what we're needing to do is to multiply this term here by our denominator of e to the power of x. So if we're working that out, if we have e to the power of 2x times e to the power of x, we have to add the powers, giving us e to the power of 3x. So what we would get is 2e to the power of 3x. Any of those final answers are all okay. We can leave it in any of these forms. Moving on to our next example. To differentiate, our rule is that we differentiate our power. The derivative of 4 multiplied by a function is 4 multiplied by the derivative of that function. We can't work out what the derivative of this function f of x is because we don't know what f of x is. And then we keep our original exponential function as is. And that's the answer. We can't actually do any more of it than. Our final example for today, we're wanting to find the gradient of the tangent. Remember, the gradient of the tangent, we do this by finding at dy dx, we're finding the derivative and we substitute in the particular x value. So we have this here. Notice that we are going to have to use the chain rule now as well. We can write this as e to the power of x minus 1 to the power of a half. So if we're using the chain rule by writing it out, we would get u equals the inside function, ex minus 1, and y equals e to the power of u. We differentiate, not dy, that's not what we're doing right now, is it? We need to differentiate with respect to u, So we get du, we differentiate u with respect to x. Derivative of ex, the derivative of x is 1 multiplied by the original function. The derivative of negative 1 is, of course, 0. dy du, we multiply by the power, and we subtract 1 from the power. So therefore, what we get is dy dx equals, our chain rule is dy du multiplied by du dx. Instead of dy du, we have 1 over 2 of u to the power of negative a half. Instead of u, I'm going to write e to the power of x minus 1 to the power of negative half multiplied by e to the power of x, which we can write with positive powers. Remember, negative powers move to the denominator. half is the same as a square root, and we get our answer here. You could have used the shortcut method of the chain rule, and that would be entirely your choice and entirely welcome as well. Finally, we want to find the derivative or the gradient of the tangent at this point, so we need to substitute in when x equals 0. When x equals 0, what we will get is e to the power of 0 over 2 square root of e to the power of 0 minus 1. Anything to the power of 0 is equal to 1. In the denominator here, 1 minus 1 is 0. And what we're finding is that we get 1 over 2 times 0 is 0. What happens when we have when we divide by 0? We get an undefined gradient. And that is actually our final answer. The gradient of the tangent to the curve at that point is undefined. Okay, so that's it for today. Hopefully this was helpful. If you have any questions, please make sure you make a note of them and ask them when we're back in class again.